So when we're solving a 3 by 3 linear system, when we say that, we mean 3 variables by 3 equations. We've already done some 2 by 2 systems, that's no big deal, but a 3 by 3 system is a little bit tougher, right? There's a little more to it. Now the good news is we're gonna come up with, or I'm gonna show you a trick for, not really a trick, I'll show you a method for solving large linear systems using technology that relies on using matrices and technology. We're not gonna, in the past, I have some, on certain years, with the honors class, I've talked about doing some matrix algebra and taught that a little bit, but I just don't think I'm gonna do it. I think it's stuff you'll see, I don't know, you probably won't even do it next year. It's stuff you'll see in college, but I don't really want to take up too much time with it right now. If there's time at the end of the year, we can come back and I can show you some stuff with that if we have time left over after we've covered everything we need to cover. But I'll at least show you how to use a calculator to get answers, right? Okay, so what are we going to do here? We've got 3 variables, x, y, and z, and somehow I've got to solve for the ordered triple, right? That's going to be a solution. There are other possible types of solutions that wouldn't correspond to a point, but we're not going to see any of those today, and I don't want to talk about those until after I've showed you, until we've had to talk about what a 3-dimensional linear equation looks like. And so you have some kind of sense about what this, so you can visualize this a little bit. It doesn't really make sense to talk about the other types of solutions. So what do? Okay, there's some steps we can follow. And we kind of want to maybe look at this and try to think in advance a little bit. We want to try to figure out if there is a variable that we could eliminate from 2 different pairs of 2 of these equations taken together. So like, for example, like if we were to take, we could call these equations A, B, and C. If we were to take equation A and equation B, could we eliminate a variable from those 2 by using elimination, just like we did previously, by multiplying both equations potentially by a number so we can add vertically and eliminate a variable? And then could we do the same thing for a different set of 2 variables, or 2 equations? In this case, does everybody see that the y's would be pretty easy to get rid of, right? Like if I were to take these top 2 equations, and let's start this process. So if I take these 2 equations right here, I could leave the top one alone and multiply this one by what to make the y's cancel? Six. Anybody see that? To make the y's cancel? So the top one would just give me 2x minus 6y plus 9z equals -8. If I multiply through by 6, I'm going to get 30x plus 6y plus 12z. I've got to give myself a little more room here. Equals 60. And if I add those up, the y's cancel, right? Everybody see that? So I eliminated the y's, and what do I get? If I add those up, I get 32x plus 21z equals 52. Did I do all that right? Anybody see any mistakes? Okay, so we eliminated, now what did we accomplish there? We eliminated the y's, right? So now, strategically, does it make sense that I want to do the same thing and eliminate the y's again from a different combination of 2 equations? If I did the same thing and eliminated the y's, then I'm going to end up with 2 equations in 2 variables. And what did we really do? We collapsed that 3 by 3 system down into a 2 by 2 system that we can easily solve using all the techniques that we've already practiced, right? So the other two really easy equations to use would be the bottom two, right? I could leave this one alone, and what would I multiply the bottom one by to get the y's to cancel? -1. So I end up with 5x plus y plus 2z equals 10, and -3x minus y plus 8z equals positive 28, right? Add those up, and again, the y's cancel. So I'm going to get 2x plus 10z equals 38. Good? Okay, now I'm going to combine. I've eliminated the y's from these two equations. I'll combine these into a smaller 2 by 2 system. And I've got 32x plus 21z equals 52. And this other equation, 2x plus 10z equals 38. Okay, do you see anything I could have done here that would have maybe been helpful? To simplify that equation? Yeah, why not divide both sides by 2, right? That would have been kind of helpful, wouldn't it? If I divide each side through by 2, I'm going to get x plus 5z equals 19. And that makes this bottom equation at least a little bit simpler, right? I've just got an x (5z) and 19, and it may not be that big a deal. It looks like I'm going to have some pretty bad numbers here, but which variable do you suppose we probably want to get rid of? Probably the x's, right? And I'm going to get some big numbers, and what am I going to have to multiply the bottom equation by? -32. Yeah, so this one's going to stay the same. This one we're going to multiply by -32. And that gives us 32x plus 21z equals 52. And -32x minus 160z equals 320 minus 32 is 288, so -288. And the x's cancel, right? And so we end up with what's that going to be? -139z equals, no, hold on, what the heck happened here? Something bad happened. -139z equals, did I make a mistake there? Because that doesn't seem like that's going to work out. And I don't think this is supposed to be a fraction. I think this one's supposed to work, as I recall, this should probably work out so we get integers. So that's, oh, maybe it works. Well, I don't think so. I get -236. Did I multiply that right? It's 32 times 19, is that 288? Oh, what am I doing? How did I get 288? It's way off. Yeah, that's, my goodness. What was I thinking? I don't know. Way off. Okay, so then what does that give us here? Then now, so this is going to be okay now. So now we're going to get negative 556. Is that right? 2, 5. Yeah, okay. So if I divide each side by 139, that gives me 4, doesn't it? Right? Okay, so there's the first part of our ordered triple, right? We get a z equals 4. What do I do to find x? Good. We'll plug it back into, well, okay, plug it back into, right, these equations here, right? Good. We'll pick the easiest one because this whole part down here, remember, at the bottom, this is like its own little mini problem, right? We're just solving this little 2x2 system. So I'm going to plug back into the easier of the two equations, which looks to be that one, right? So that's going to give us then x plus 5 times 4 equals 19. So x would equal negative 1. Everybody agree? Okay. We're 2/3 of the way done. Actually, probably more than that. Now where do we go? Yeah, any one of the first equations and plug those in and solve for the remaining variable, which is a y, right? So how about if we pick this top one, for example? If we pick this top one, we're going to get 2 times negative 1 minus 6y plus 9 times 4 equals negative 8. So what's that give us? We got 36 minus 2 is 34. So 40. So I get what, 7 for y if I solve that? I'm going to get negative 6y equals negative 42, right? So this gives us y equals 7. And we got it. We got our ordered triple. Okay? So our answer looks like the ordered triple negative 1, 7, 4. Okay? Make sense? So again, what's the strategy? You're going to target a variable that you can eliminate from 2 different pairs of equations. And then by eliminating that variable, you're going to get 2 equations with only 2 variables that you can combine into a small system, a small simple system. Okay? What do you suppose you would do algebraically to solve a 4x4 system? Same thing, wouldn't you? You'd be doing the same kind of process, right? I'd have to, with a 4x4 system, I'd have to combine, this would get to be pretty tedious. With a 4x4 system, I would have to get 2 groups of 3 equations where I could eliminate one of the 4 variables from each of those 3x3 systems. Does that make sense? See what I'm saying? Or I'd have to do it, I'd have to pick 3 different, let me say that again, I'd have to pick 3 different pairs of equations that I could eliminate a variable from to collapse that to a 3x3 system. Then I'd have to pick 2 different pairs of equations to eliminate a variable from to collapse it to a 2x2 system, right? So as you work your way up, you can see if you were trying to solve like a 9x9 system, wow, yikes. You have to start off by picking 8 pairs of equations you could eliminate 1 variable from to get an 8x8 system. Then from that one, you got to pick 7 pairs of equations you could eliminate a variable from to get a 7 by 7 by 7. Can you imagine how long that would take? And that would be a long, long, tedious process. But when all the dust settles here on this unit, I'm going to show you a trick where you'll be able to do a 9 by 9 system in about less than a minute. You know, probably a minute. It takes a little while to type the numbers in, right? Okay, so I wanted to show you an example so you could get started on this. I mean, they're all pretty much the same. Do you want to do another one? You think? I mean, it's the same kind of thing. You're just the same strategy. So maybe we'll go back. Now that you know how to do this, I'll put the assignment up. You can start to work on it. Next time we meet, we'll do another one of these. It's probably just a little example, kind of refresh your memories on it. But let's go back and let's talk about. Let's kind of talk about what all this stuff means. Okay, so where we left off yesterday, right, we were talking about what it would mean to be able to unfold a net of a 4-dimensional object, right? This is where we kind of left off. If we take a cube, a 3-dimensional object, you'll remember doing this. If I unpack a cube, if I unfold a cube to create a net, the 3-dimensional cube has a 2-dimensional net, right? What would a 2-dimensional object, what kind of a net would a 2-dimensional object have? 1-dimensional, and we could show that. I mean, I hadn't even planned to talk about this, but that's kind of interesting, I guess. So if we have a, how could I do, I'll draw it like this. Might as well play with my toys a little bit while I'm doing this, huh? So, okay, if I take this square and let's mark all the vertices of the square in red so we can keep track of those. That's 2-dimensional, right? If I unpack that into a 1-dimensional net, what's it going to look like? Yeah, it's just going to look like, it's going to be pretty boring, isn't it? It's just going to look like this. Something like that, right? That makes sense? And theoretically, if I were going to take a 1-dimensional object and unpack that, it's going to fold down into a 2-dimensional would fold up into a 1-dimensional. 1-dimensional would fold up into a 0-dimensional, would just be a point, right? Okay, but what may be more interesting is we can't visualize what a 4-dimensional cube would look like, which is called a tesseract. Sometimes people call it a tesseract. We can't imagine what that would look like, but its 4-dimensional object would have a what dimensional net? 3-dimensional net. So we should be able to see what the net of a 4-dimensional object would look like. Okay? And here it is. That's one way you could unpack a hypercube. There's different ways you could do it, right? I mean, just like there are different ways you could unpack a cube. If I start with a cube, there's several ways I could do that. Like I could unpack it like this, right? I could unpack a cube like that, couldn't I? If I folded all those up, that's going to make a cube, agreed? Or I could do something slightly different. I could maybe go let's see, I could go, here, we'll do this. This will make it a little easier to do. That would work, wouldn't it? Agreed? So there are some different ways to do it. Yes? Mm-hmm. It is. So that would be a hypercube or a tesseract. And how would you make that? Well, you can't. Here's a little animation that you know, I mean, you have to take this with a grain of salt. Whenever an animation shows you a picture of a tesseract, that's not realistic because you can't see a tesseract. But it kind of gives you an idea how it would work. You can see that little animation up there. So it's going from 1D to 2D to 3D. Now here's what 4D would have to be. Can I pause that thing? Yeah. So how does that work? Like when I start with 0D, there's 1D. When I go to 2D, I'm always moving at right angles, agreed? So now I'm going to move at right angles to those corners, right, to create, or go back to create my 3D object. There's no other place to go with 3D, but somehow there's got to be some extra space in there where you could carve out another 3D angle. We can't see it, but somebody who is a four-dimensional creature would say, oh yeah, it's right there, it's obvious, okay? One thing about this I do kind of like, and that is that it gets, these are a little bit hokey, but the angle is carved out inside, because think about what volume would be like. What's the, so in 1D we would talk about length. If we've got a unit square, right, so the sides of the square are 1 by 1, right? So in 1D that would just be a 1 unit line segment. So the length would be 1, right? If we move to area, to 2-dimensional, then we get 1 times 1. So we get a square with an area of 1 square unit, right? We move to volume, cubic space, where we've got 1 by 1 by 1. We've got 1 cubic unit. By extension, what should the 4-dimensional volume be? Should be 1, shouldn't it? Right? That makes sense. It should be 1 still. I mean, it would be the unit would be like, if we're measuring in meters, it would be a meter to the 4th, which doesn't make any sense, does it? Right?